it is important for us to understand the um, pressure variation in a fluid, no? If the fluid is at rest. Okay, so um, just like what we have here in the illustration, okay, that this particular dark portion that looks like a black, that's actually the element of fluid or the uh, portion where we are interested to look into, no? And we are looking at the pressure, the amount of pressure that we have here at this particular level. Okay, and take note that what we're also doing is that we use the y-axis that refers to the elevation, no, of the um, fluid. Okay, so okay, we are going to use this block, no, to illustrate the different forces that acts on it. Okay, so we have different types of forces that we see here. So we have the downward force, which is denoted by this one. Okay, and also the upward force in response to the downward force. This one, the PA, and we also have the force due to the gravity. Okay, that is denoted by the dW. Okay, the dy here only refers to the change of the elevation, no, of the uh, fluid. Okay, so again, the downward force is P plus dP times dA, and the upward force is the P times A, pressure times the area, and the weight force is the density times the gravity times the area and the change of y, or the change of the elevation. So we're going to use the three different quantities here: the volume, the mass, and the weight. Okay, so the volume here is denoted by dV, which is equal to area times the dy, and mass is dm, that is equal to density times the dV, or the change of volume, or equal to uh, density times area times the dy, and the weight is dw, that is equal to dmg, or mass times the gravity, and also equal to the density times the gravity and times the area and the dy. Okay, now we have to look into the units. We're going to look at it if uh, these are really talking about the quantities that we are discussing here. So the dV, so since, okay, the area is meter squared, the dy is meter, so that's a cubic meter, so that is for the volume, and the dm, or for the mass, that is equal to this one, the density area times the change of y, or the dy. So the density is kilogram per cubic meter times the meter square times meter. So the cubic meter here are cancelable, so the remaining unit is kilogram. Okay, so this is for mass. And for the weight, uh, density times the gravity times the area and times the dy, which is the density is kilogram per cubic meter, the gravity is meter per second squared, area is meter squared, and for the dy is m. Okay, so the cubic meter here are cancelable, so what's the remaining units are kilogram and meter per second squared, and that is Newton. Okay, so dW, okay, Newton. So we just evaluated the different units. Okay, now next. Okay, since the fluid is at rest, meaning the net force is equal to zero, they are at a state of equilibrium. Okay, so we are going to look at the three different forces here. okay, and equate that one with 0. Okay, so PA, the upward force, minus the downward force, this one, okay, minus the weight force. Okay, so take note that the three terms have common quantity, that is the area. So we can cancel out these three common quantities. Okay, so that is why we have here the P minus P plus dP minus density times gravity and the dy. Okay, and we can eliminate the P, okay, here. So we have negative dP minus density times g times dy. Okay, all right. Okay, here. Now, or we can express that one as negative dP equals rho, or the density, times gravity and times the dy. Okay, or dP, if we're going to transfer uh, the negative sign to the other side, that is dP equals negative density times the gravity times the dy, or the change of elevation. Now take note that the density and the gravity are constant. All right, they are constant. And if we're going to describe these quantities, we can use the dP over dy, meaning in every change of elevation in the fluid at rest, the pressure is changing. Okay, that's the meaning of this expression here. Okay, right. So this is expression of the differential, no, dP and the dy. So we have the p sub 2 minus p sub 1 is equal to the negative density times the gravity and times the change of the elevation. Okay, so it is negative because the all of the forces are actually directed downward. Okay, if we can remember our, if we still remember our Cartesian plane, so we have the y axis going downward, it's negative. Okay, so that is how we derive the expression for change in pressure between the depths of the fluid. Okay,